Okay, so if you guys remember last week when we did 4.4, we looked at acids and we looked at bases, and towards the end of that PowerPoint, we started looking at acid metal reactions. So we learned about 3 specific types in that table there. The first one was reaction of acids with metals, which is the first type we're going to go through today. Then we also looked at reaction of metal oxides with acids, okay? And the last one we looked at was reaction of metal carbonates with acids. So just 3 types of reactions that occur when acids interact or combine with a metal, okay? Either a metal by itself, a metal oxide, or a metal carbonate. Okay, so that's the basic, the 3 types. So what we're going to go through today is we're going to kind of follow that formula that we looked at in last class, basically showing you that every time we've got a metal and an acid combining, we've always got one specific salt that forms out of that, as well as some constants. Constants means elements that kind of just are the same, regardless of what equation we attempt or try to do. So if we look at the first example here, we can see that with acid and metal reactions, we've got a metal which is lithium. Okay, so let me just get this. Okay, so we've got lithium, that's our metal. Sulfuric acid is our acid, okay? When that combines, the formula tells us that we always get a salt, or in other words, a metal salt that's formed, as well as hydrogen gas, okay? So that's lithium sulfate plus hydrogen there. Let me just let these people in. Okay, so there's also a specific rules, and it's written here as well for you, but I'll just quickly jot it down here as well. Whenever we have sulfuric acid involved in a reaction, we know that the metal salt that's going to create is called sulfate. Okay, when we have hydrochloric acid involved in a reaction, we know that the metal salt that's going to form as a product is chloride. Okay, and whenever we have nitric acid involved in a reaction, we know that the metal salt that will form from that is nitrate. Okay, so this is kind of like a formula or a kind of thing that we can apply to any equation that we get. Okay, just going to put that on the side for now. So that's the basic idea. So if we look at the first one now, guys, calcium is our metal plus hydrochloric acid. Now, given that all you've got to do is take the name of the metal, sorry, let me change this. Okay, take the name of the metal and combine it with the name of the salt that's formed. Can anyone in the chat box, or as many people as can give this an attempt now, can you guys tell me what's the name of the salt that's going to form here in the first box? Okay, you can look to the previous example to get an idea. Tell me the name of the metal salt that's going to form in this box here. Okay, so we've got calcium is our metal. Okay, so the first thing we can do is write calcium. Now, what kind of salt did we say hydrochloric acid forms? We said that it forms chloride. So all we do is write calcium chloride. Now, does anyone have an idea of what we're going to put in our second box there? It is a constant. Hydrogen, excellent, okay? So hydrogen is going to be constant. It's going to be the same for all of these. Okay, so calcium chloride plus hydrogen, that's going to be our worded equation there. Okay, and we can also write this as a chemical equation as well. So if we were going to write that as a chemical equation, I don't have space, but I'll show you some examples at the bottom of that page there, okay? So that's basically the first one. Now I want everyone to, and by everyone, I mean everyone, to give an attempt for number 2 now. Okay, so number 2 is magnesium plus sulfuric acid. So remember what you're going to do now, guys, is you're going to take that magnesium, just chuck it into the first bit of your answer. We already know that magnesium is going to be the first bit here. Now look at what kind of salt forms from sulfuric acid. And can anyone tell me the name of the compound that I'm going to put in this little line here? Excellent, magnesium sulfate, okay? Where did we get sulfate from? Well, we know that when sulfuric acid is a reactant, that sulfate is the metal salt that will form, okay? These are the acids, And on the right-hand side, these are the names of the salts that form. So here we're going to write, we'll just let some people in. Okay, so here what we're going to write is, if I can make it smaller. Okay, no, I'll try it the other way. Okay, so here we're going to write magnesium sulfate. Okay, and what's our constant, guys, that we always have in the second box there? It is hydrogen. Okay, that is our constant. Remember, guys, we always have hydrogen. That is always the constant. See, that's there, it's there, it's there. The only thing that changes is the name of the metal salt that's formed, depending on what metal is there, as well as the acid that the metal combines with. Okay, I want everyone to try the next one. So the next one is lead. Okay, lead, which is one of our, metals or transition metals, and nitric acid. So what's the name of the metal salt that's going to form from lead and nitric acid? And some of you in the chat have already got the answers there. Good work. So I'm going to give everyone a chance to have a look at that now. So lead plus nitric acid, what kind of metal salt will form from that? Excellent, good work, guys. So most of you are giving me the correct answer there. It's going to be lead nitrate. Okay, we know this because whenever we have nitric acid as a reactant, that means whenever we see nitric acid on the left-hand side of the arrow and it's combining with a metal, in this case lead, we know that a metal salt is going to form. And in our case, that metal salt is lead nitrate. Okay, and what's our constant going to be? The same as before, yeah. So it's going to be hydrogen. Okay, hydrogen is going to be our constant. That never changes. That's always there. Okay, hydrogen or hydrogen gas will always be a product of that acid metal reaction there. All right, let's try the next one now. Can anyone tell me? And this one, they've actually, you have to figure out what acid was involved in this reaction. So iron has combined with something, has combined with an acid to form iron chloride. So you're just kind of working backwards now. So the first, what are we going to have in the first box here? If we look at our acids and salts, the first one is going to be hydrochloric acid. Excellent. So hydrochloric acid. Okay. I'm just writing this in actual words, even though it'd be easier to write them in symbols, because here we're dealing with worded equations, guys. So whenever we ask you to write a worded equation, you shouldn't be putting chemical symbols in the worded equation. Okay, so iron chloride is going to be the product, and obviously the constant, just as above we've seen, is again going to be hydrogen. Okay, hydrogen gas. Okay, so try the next one now. Zinc combines with sulfuric acid to give us a specific metal salt. The constant has already been given to us, which is hydrogen. Can everyone, or can as many people as possible in the chat, tell me what salt is going to form here in the products? The first product before hydrogen, what's going to form? Yeah, excellent. Got some good answers there. The answer will be zinc sulfate. Okay, because we know sulfuric acid is connected, when sulfuric acid is in an acid metal reaction, it will form the salt known as sulfate. So all we're doing is we're connecting that there. So zinc sulfate will be our answer. Okay, and this one is again similar to the previous one where you're kind of working backwards. So they've given us the fact that tin nitrate was the metal salt that's formed. So now you guys need to tell me what is the name of the acid that took part in that reaction, going by our formulas or going by our thing. These 3 points we've got here. Good work, nitric acid, excellent. Okay, so we know that when tin and nitric acid combine together, we've got tin nitrate. Okay, now that's basically all of our worded equations done from 1 to 6. Okay, so those are worded equations. They're kind of easy because you're not dealing with chemical symbols. You don't have to go back to your periodic table to, maybe look at what a chemical symbol represents, all that stuff. But we also have to deal with chemical symbols. In fact, it's more important for us to be able to know how to deal with chemical symbols. So what we're going to do is I'm going to have to scroll down now. So I'm just going to clear these drawings and scroll, whoops. Okay, scroll down. Okay, so we're dealing with these three here now. Sorry, these last two ones. So we've got calcium plus hydrochloric acid. Calcium plus hydrochloric acid combines to give us something plus hydrogen gas. Can anyone tell me what will be the chemical symbol, okay, that will be represented for the blank here? Okay, if we've got calcium and hydrochloric acid combining, you can write the worded answer first and then work out the chemical symbol from there. Excellent, good work. So everyone is saying calcium chloride, okay? Calcium chloride is correct. Be careful with how you write that. Remember, calcium chloride is actually represented as CaCl2, not CaCl, because remember when we're talking about writing chemical equations, we always have to understand that the valencies influence the final symbol. So Ca has a 2+ charge where Cl has a -1 charge. And remember we said they swapped the charge. What am I doing? They swapped the charges there. So this is going to be Ca takes on that +1 charge, or sorry, -1 charge of chlorine. That goes like that. And then Cl is going to take on the 2 attached to the calcium. We usually don't write Ca1, so that's going to just end up being CaCl2. Okay, so that's going to be the correct answer there. And they've already balanced the equation here. As you can see, they've put a big 2 in front of the HCl, so that's already balanced. Okay, what about the next one now? So the next one says magnesium plus something, so we're kind of working backwards now, gives us magnesium sulfate plus hydrogen. So have a look. In this one, you'll have to actually look at your valency table, okay? Because this one is not as straightforward as the previous one. So you can have a look at your valency table. Excellent, good work. So when we've got magnesium sulfate here, we have to remember that sulfate was formed as a result of sulfuric acid. Now, if you Google, even if you just Google sulfuric acid online, you'll be able to find out that the chemical formula for sulfuric acid is H2SO4. And we know from our valency table or polyatomic ions that SO4 is just the symbol for sulfate, okay? Sulfuric acid can be a little bit confusing because it has different names, okay? So when we're talking about sulfuric acid, it's known as sulfuric acid, that's one name for it, but it's also known as hydrogen sulfate. In some books, it's even known as dihydrogen sulfate because of the fact that it's got di or 2 hydrogen atoms. So if you ever see these different terminologies used for sulfuric acid, just know that they're all referring back to the same thing. They're all referring back to sulfuric acid, okay? Hydrogen sulfate is, another word for it. That's why the formula looks like it's got hydrogen and it's got sulfate in it. And as we learned about in 4.4, guys, remember all acids contain hydrogen, okay? They all contain hydrogen, and basically that's why we said acids donate. They donate that hydrogen proton or hydrogen ion when they are in an acid-base reaction. Okay, so hopefully that makes sense about the first type of reaction there, which is our reaction of acids with metals. So now we're going to move on to the next one, and we're still using the same basic concepts here, just sticking with our formula. And this is reaction of metal oxides with acids. Okay, so this is when an acid combines with a metal oxide, and again gives us a metal salt, and also gives us the constant variable or constant product of water. Okay, so we're going to look at the first example here, and the first example tells us copper oxide, copper being a metal, oxide being, copper oxide just being an anion. Okay, and then sulfuric acid is basically our acid involved, and then copper sulfate is the metal salt that's formed, and then water. So water is the constant. Okay, so if we're going to write down our, just because we don't have it on this slide, let me quickly write it up again so we can refer back to it. So again, just the same idea. Sulfuric acid gives us sulfate. Nitric acid gives us nitrate, and what's the other? Oh yeah, sorry, hydrochloric acid gives us chloride. Okay, so referring back to the same thing. If we've got magnesium oxide combining with nitric acid there, we have to think about what are the two formulas that are going to be involved. What are the two products that are going to be formed as a result of that? Okay, so the first thing I think we can all agree, what's the first constant going to be? Or the second, what am I going to put in that second box there? Remember, we're no longer looking at hydrogen. Hydrogen was for metal and acid reactions, but now we're looking at metal oxides, which are slightly different. So according to our formula now, it's a different type of reaction. So our constant is going to be water. Okay, so water is the correct answer there. So what we're going to do is we can just write water. Okay, that's going to be our constant. And as we can see, that's reflected above there as well. Okay, now we're going to fill in this box here. Okay, and this box is basically representing the name of our metal salt. So if we look at the metal that's involved here, it's magnesium. Okay, and magnesium is combining with nitric acid. Okay, so I want you guys to think about what's the name of the salt that's going to form here that I'm going to put in the first box. Good, magnesium nitrate, excellent. So we're just going to write that there. Magnesium nitrate. Okay, we know it's nitrate because as per our formula, or as per our template, we know that when nitric acid is involved as a reactant, it produces the metal salt known as nitrate. Okay, good work. Let's move on to the next one. So the next one is basically silver oxide plus hydrochloric acid. So let's get rid of the constant one first. So we get one blank filled there. What's going to be our constant variable here? Our constant product. Again, same thing, water, just the same as above. That's always going to be constant regardless of which question we do on this page. Okay, so water is the constant. Now we've got to figure out what's the name of the metal salt that's involved or that we're going to put in our first blank here. So we've got silver is our metal. Combining with hydrochloric acid, we know hydrochloric acid usually produces the salt known as chloride. So then we just match them up, silver, chloride, and we write that here. Yeah, excellent. Good answers there in the chat. So silver, chloride. Okay, so that's going to be our the correct products there that are identified. Okay, awesome. So let's move on to the next one now. So now we're looking at lead oxide plus sulfuric acid. So again, our constant is going to be same as above. It's just going to be water. Okay. Now, what's going to be the name of the salt that forms when lead oxide combines with sulfuric acid? Yeah, lead sulfate. Excellent. Good work. So lead sulfate is going to be the name of the metal salt that forms, okay? Because we've got lead here combining with sulfuric acid. We said that sulfuric acid produces the salt known as sulfate, okay? So all we write here is lead sulfate. I can't write on this thing. Okay, that should be sulfate. Okay, so lead sulfate plus water. That's going to be our metal salt. Okay, guys, all we're doing here is we're just following. When we're talking about the three different types of reaction, each type of reaction has a formula, which we can see here. All we're really doing is we're applying that formula, okay, to each question that we get. Depending on the metal and depending on the acid that we get in the question, the name of our metal salt or the first blank here will be different, but water will always be the same. Look, water, 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 water. That's always going to be our constant product as per our chemical formula or chemical template there. Okay, so let's try the next one now. So we know that our constant is water, so I'm just going to go ahead and write it down there. Can anyone tell me what's going to be the name of the salt that's formed when copper oxide combines with nitric acid? So we're filling in our first blank here. Yeah, excellent. Good work. Copper nitrate. That's correct because copper, okay, combines with nitric acid, and we know that nitric acid forms a salt known as nitrate. So we just connect the two, copper nitrate. So we can write that down there. Copper, can't write on this thing, nitrate. Okay, hopefully that's readable somehow. Nitrate. Okay, so copper nitrate plus water, so that's correct. Alrighty, now we're getting to our actual chemical equation bit. So the word equation ones are pretty okay, I think, but when it comes to the chemical equation bit, that's where it can get a little bit confusing. So the first one we're doing, okay, I want you guys to now look into your periodic table, figure out what SN is. I'm not going to tell you, or, you know, just Google it, and then figure out what's the name of the blank that's going to come up here, okay? Remembering that H2SO4 represents hydrogen sulfate or sulfuric acid. Yep, SN is tin, good work. So SN is obviously going to be tin oxide. So if how can I write that here in a way that's not going to... So basically this is, if we're going to write this in words, it's going to be tin oxide plus sulfuric acid, just to give you guys a clue. Okay, let me just put that above a little bit like that. Okay, so now I've given you guys a clue. Tin oxide plus sulfuric acid. What's the name of the metal salt that's going to form? Tin sulfate. Excellent, good work. So tin sulfate. So see, it's just a matter of knowing how to read the chemical equations there. Okay, that's the only bit. If you know how to read it, it's pretty easy for you to arrive at the correct answer there. So tin sulfate is correct. Okay. The reason being that H2SO4, remember, is the chemical formula for sulfuric acid. And we know that sulfuric acid produces the salt known as sulfate. So then we just connect tin with sulfate. So tin sulfate is the metal salt. Okay, now we're working backwards. So now we've got to figure out the second blank here. They've given us the name of the compound here, or the metal salt, sorry, that's formed. Now look into your periodic table or Google online, and can anyone tell me, I don't want to give you the answer, but can anyone tell me what is Cu? What's the name of the metal represented by chemical symbol Cu? Copper, excellent, good work. So this is obviously saying CuCl2, which is basically the chemical formula for copper chloride. So now working backwards, can we determine now what is the name of the acid that was formed? If copper chloride is our metal salt, what was the name of the acid that was the reactant in this reaction? Yeah, so copper chloride, so we've got chloride here. And if we work backwards, we've got hydrochloric acid. Yeah, correct. So we would write that here. Oh, sorry, we would write that as, go back. We would write that as HCl. Okay, making sure we use proper use of our cases. Okay, so HCl is our formula here. This is not balanced. In order to make this balanced, I'd have to put a 2 in front of that, okay? Just to make sure that we've got an equal number of atoms involved there, okay? But that's the basic idea, okay? So let's move on to the last one now. The last one talks about Ca. We all know what Ca is, so I'm just going to say it's calcium, okay? Calcium oxide plus HNO3 is actually the chemical symbol for nitric acid. Okay, just because you guys might not know that already, or you might have to look into a valency table to see that, or polyatomic ion table to see that. NO3 is usually nitrate, but remember we said acids contain oxygen. So that's why hydrogen nitrate or nitric acid is basically HNO3. That's why we've got the H in front of it, okay? Because all acids contain hydrogen. So can anyone guess what's the name of the metal salt that's going to form here in the first blank? If you don't know the chemical equation, it's fine. You can just write the word for it. So we've got calcium is our metal. Okay, let me write that down like this. So calcium oxide plus nitric acid. This is what we're dealing with. Okay, so can we determine now what is our name of the metal salt that's going to be formed? Yeah, good. Calcium nitrate. Yeah, excellent. Okay. So basically, we get that because calcium is the metal that's involved, and nitric acid always produces the salt known as nitrate. Okay, so calcium nitrate is going to be the correct answer. So we can write that down there. If we were to write this down in terms of a worded equation, we would write calcium nitrate plus water. Okay, but if we're going to write it down as a chemical equation, we just need to write down, where's that thing gone? It's going to be Ca NO3. Remember, NO3 nitrate is a polyatomic ion, so NO3 2. Okay, how do we get this equation? Because if we combine calcium and nitrate together, calcium has a 2+ charge, okay, whereas nitrate has a NO3. And NO3, this entire thing has a minus charge or -1 charge. So when we combine them together, what we really get here is Ca, and then we open the bracket NO3, and then we put the 2 outside. Okay, because remember, polyatomic ion, if you're representing swapping of charges there, you've got to put the subscript on the outside. Okay, so that's how we get that equation there. Okay, so that's basically calcium nitrate's equation. Alrighty, any questions so far, guys, about anything that we've done so far? All good? Okay. Alrighty, so what we're going to do is we're going to go on to the last type of equation now. And now we're looking at what happens when acids combine or interact with metal carbonates. Okay, we're still dealing with metals, but rather than magnesium oxide now, we're dealing with magnesium carbonate. Okay, so this is the general equation for carbonates. We've got a metal carbonate reacting with an acid gives us the metal salt plus water plus carbon dioxide. So here you've actually got now 2 constants compared to before. Before we only had one, it was either hydrogen gas or it was water. Now we've actually got 2 constants, okay, which is why we've got now 3 blanks or 3 gaps that we need to fill in for each one. Okay, now if we look at the first one, which is, if we look at the example, calcium carbonate plus nitric acid gives us calcium nitrate. Again, just using the rule about acids and the salts that they form. Water is the constant, carbon dioxide is the constant, okay? So what we can actually do, guys, is we can literally just write down the constants for every equation because they're going to be the same. So I could just go around and write water for each one or carbon dioxide for each one in the second and third blanks there, because that is going to be constant for everything. So let's do them one by one, and maybe I'll leave like 1 or 2 for you to work on your own as well. If we look at the first one now, magnesium carbonate plus hydrochloric acid, let's fill in the constants first and then deal with the salt. So if we look at the constants here, what are the 2 constants going to be, guys, that I'm going to use to fill in gaps 2 and 3? Yeah, excellent. Water and carbon dioxide. So we're going to write water, and then we're going to write carbon dioxide. Carbon dioxide. Okay, so that's the basic, those are the constants there. Now we need to figure out the name of our metal salt that's going to form. So if we've got magnesium carbonate and hydrochloric acid, what's the name of the metal salt that's going to form there as a result of that? Magnesium chloride. Excellent, good work. So we're going to write that here. Okay, the reason magnesium chloride is going to form is basically the same as before. We're using the same rules. When we have hydrochloric acid, we know that the name of the salt that's formed from hydrochloric acid is chloride. Okay, and then we just match magnesium with hydrochloric acid salt, which is chloride, to get magnesium chloride. All right, let's try the next one now. So the next one, again, our constants are going to be water and carbon dioxide. So let's just write them down first, get them out of the way. Carbon dioxide. Okay, now I want you guys to figure out what is the name of the metal salt that's going to form as a result of this now. Yeah, sodium nitrate. Excellent. Good work. Because we've got sodium is our metal. Nitric acid we know forms the salt known as nitrate. So that is going to form sodium nitrate there. Good work. sodium nitrate. Okay, now the next one I'm going to give you guys to do all by yourself. So you've got the equation there. In the chat box, let me know what are the three products that we have. So you just put a plus in between them when you type out your answer. And yeah, let me know. So I'll give you guys like maybe 45 seconds to do that. 30 seconds. Yep, good. Already getting some good answers there in the chat. Good work. Come on, guys. Everyone needs to be contributing. Great work. So, yep, it's going to be calcium sulfate. Water and carbon dioxide. So that's correct. Good work. Carbon dioxide. Oops. Just get that carbon dioxide. Okay. Now let's try the next one. So I want you guys to tell me now what are the names of the three products that are going to form as a result of potassium carbonate interacting or combining with hydrochloric acid. So again, about 30 seconds should be enough, I reckon. Yeah, good work. So the first one is going to be potassium chloride. Okay, because hydrochloric acid produces the salt known as chloride. So we just attach that to our metal that's involved here, which is potassium. So potassium chloride. And then our two constants are going to be water and carbon dioxide. Good work. All righty. So let's try the next one. The next one is a little bit different. They've actually given you the name of the salt that's formed. All you need to figure out now is what's the name of the acid to the left-hand side of the arrows. What's the name of the acid in the reactants part of that chemical equation, as well as what are the two constants. The constants are pretty easy. We know them. Just let me know what's the name of the acid that's involved there. So I'll give you guys about, it's an easy question, 10 seconds. Everyone has 10 seconds to tell me in the chat now, what's the name of the acid that's involved? Great, fantastic. Yeah, it's sulfuric acid. We know that because of the word sulfate. Sulfate is the salt that's formed, and it's only formed by one of our acids, and that acid is sulfuric acid. You can kind of look at the names, they're similar. Sulfuric sounds a little bit like sulfate, so that's how we can also match them up. Okay, and our two constants, as we know from before, are just going to be the same as they've been for all the other questions, just going to be water and carbon dioxide. Okay, now we're dealing with the tricky ones, which are the two chemical equation ones. Okay, so if we look at this, we know that CO3 is just the standard chemical symbol for carbonate. So that's going to be Ca's calcium carbonate plus hydrogen sulfate or sulfuric acid gives us something plus water plus carbon dioxide. So now, can anyone tell me, or let me write this down so it's clear actually as well. So if this is calcium carbonate plus hydrogens, we'll write sulfuric acid. We won't write hydrogen sulfate just to avoid confusion. So sulfuric acid, oh, what have I done? Okay, so yeah, that's the basic idea. So calcium carbonate plus sulfuric acid. What's the name of the metal salt that's going to form there? You can take about 20 seconds, think about it. Calcium carbonate is combining with sulfuric acid. Think about the name of the salt that's formed from sulfuric acid and then connect it to calcium. Yeah, excellent. Good work. Calcium sulfate. That's correct. Awesome. So what we're going to write is we're just going to put there Oh, sorry, we have to do this chemical symbol, not worded. If we're going to write it worded, we would just write gives us calcium sulfate, okay, plus hydrogen, sorry, plus water plus carbon dioxide, but the chemical symbol will be, sorry, okay, I'm just going to write it here because we don't have a lot of space. So the symbol will be CaSO4. Okay, how do we get that symbol? We get that symbol because we know that calcium has a 2+ charge or 2+ valency. Sulfate is a polyatomic ion. It's something that we see in our periodic table. Sorry, not periodic table, in our valency table or valency booklet. So that has a 2- charge. Remember we said that, guys, whenever we've got two elements or two substances we're dealing with and they have the same charge, they actually cancel each other out. So that +2 and that -2 go 2 - 2 gives us an overall net charge of 0. So neither of these will have any extra subscripted attached to them. So that's just going to be written like that. Obviously, sulfate is written normally with a 4 there. That's a normal subscript that exists. So that 4 is going to remain there. We're not going to get rid of that. Okay. So you can see there's no extra subscripts. That's why calcium sulfate is written like that. That's the chemical symbol. Okay. Alrighty, and you might notice sometimes I'm spelling sulfate with a SULFATE, and sometimes I'm spelling it with PH. It doesn't really matter. It's the same thing. Okay, depending on what resource you're using, it can be spelled differently, but it's all the same. All right. All right. Last one. Last one's pretty easy. Can anyone tell me now? What is the name of the compound that's represented by that chemical symbol? Excellent, good work. Sodium carbonate. Okay, we know that because Na is sodium and CO3 is the general chemical symbol for carbonate, regardless of what carbonate we're talking about, it's just the general symbol. And carbonate is also one of our polyatomic ions there, okay, that we look at. So, sodium carbonate now, plus the name of the acid is missing, that's what we've got to find out, gives us sodium chloride plus water plus carbon dioxide. So now that we know that the salt is chloride, what's the name of the acid that's going to be present there? I'll give everyone about 10 seconds to determine. Given that we know that sodium chloride has formed as a salt in the side of the product side of the equation, what's the name of the acid that was involved? Yeah, hydrochloric acid. Excellent. Good work. So obviously hydrochloric acid is represented by the chemical symbol capital H or uppercase H, uppercase C, and lowercase L, like that. Okay, so just be careful when you're writing chemical symbols. If you wrote this in a sack, this would be wrong. Okay, because of that uppercase L, which shouldn't really be there. So you need to be careful. This is the correct chemical symbol. Okay, this is wrong. So that's the basic idea. So we can see hydrochloric acid combining with sodium gives us sodium chloride. That 2 is in front of sodium there because this is a balanced equation. Okay, in order to make sure there's an equal number of sodium, chlorine, and hydrogen and oxygen atoms there, as well as carbon, sorry. In order to ensure there's an equal number, remember we used to do that thing where we balanced equations. So when it came to balancing, you had to add a 2 coefficient there to make sure there was an equal number on both sides. We've looked at balancing equations before, so that should make some sense there. Okay, guys, cool. We actually finished the whole booklet. That's good. So basically what I want you guys to do for the rest of the lesson now is see if you can try your best to write down, and this is more for your personal, for your practice, okay, with writing chemical equations. See if you can write down chemical equations for each of those answers or options that we went through, or at least a few of them. Okay, at least choose maybe 2 from each page that we've done, or you can even just work with the examples that are given there in red. Okay, write down the chemical equation for at least 2 or 3 of those and see how you go in terms of writing those chemical equations using the chemical symbols. See if you can balance those equations if they need to be balanced as well, just to get your practice in terms of balancing chemical equations. I've also put a link to that balancing equations online interactive game kind of thingy, where you can just, you know, add atoms and subtract atoms in order to make it balance. That's a really good way to practice balancing equations as well. And it's kind of like a little more fun, I guess, if balancing chemical equations can ever be fun. You know, it's a better way to do it if you are kind of getting over doing it from your textbook or doing it from worksheets, you can try that balancing equations simulation there. Okay, yeah, okay, also a reminder, wait, before I do that, I'll just probably stop the recording here.